All right, so 7.1 and 7.2 are called using fundamental identities and then verifying fundamental identities, okay? All of the stuff that's on the screen we have done before, okay? But now you're going to use them a little bit differently. So the entire idea behind this stuff is substitution. We are substituting things in for what other things that are equivalent, okay? You are simplifying expressions or you are verifying, and the whole goal here is to be able to see things and replace them. So if there's stuff on this screen that you need to obviously review, I would say it's been a little while since we did the cofunctions and the even odds and the Pythagoreans. Hopefully we know our reciprocal functions. But all of these things you want to know, okay? So I actually have a Quizlet that has like all these like one side and flips the other side, but you need to know everything on this screen. Then that is really all you need to know for those two sections, okay? But then it gets applied in different ways. So if you were to see something that said secant, for example, you could replace it with 1 over cosine. If you were to see something like tan of negative x, you could replace it with negative tan of x. So different parts of these statements are going to get replaced with what they are equivalent to. This first group is the reciprocal identities. So cosecant is 1 over sine, secant is 1 over cosine. Cotangent can either be written as 1 over tangent or it can be written as cosine over sine. So you can replace cotangent with either of those or vice versa. If you saw a statement that said cosine over sine, you can replace it with cosine. Tangent would be sine over cosine. It could also be 1 over cotangent, but we don't do that a whole lot. But you could also do that. Then you got your Pythagorean identities. So these were the ones, it's been like a chapter, I guess, probably since we saw these, right? So sine squared plus cosine squared equals 1. If you took all of those and divided by cosine squared, you'd end up with the second one, which is tangent squared plus 1 equals secant squared. And if you took that original one and you divided everything by sine squared, you'd end up with 1 plus cotangent squared equals cosecant squared. So a lot of times you'll see something like tangent squared plus 1, and you would replace that with secant squared. So you're just making it a simpler statement. The even odd identities, okay, remember cosine, the sign goes away, but everything else would stay. So if I had sine of negative x, it would be the same thing as negative sine of x. If I had tangent of negative x, it would be the same thing as negative tangent of x. And then all the cofunctions, and for me, I don't know why, but people struggle with cofunctions a lot, and to me, they are the most easily identifiable. They are the only ones that have pi over 2 minus something next to them. So if you saw in a statement secant of pi over 2 minus u or theta or x, whatever that variable is, you could replace it with cosecant. If you saw cotangent of pi over 2 minus u, you would replace it with tangent. So sine goes with cosine, tangent goes with cotangent, and secant goes with cosecant, okay? Those are cofunctions. So the whole goal here is to use substitution to simplify the expression. Sometimes we get it down to one trig function. Sometimes you don't, okay? It doesn't mean you have to. Sometimes 1 is your answer. Obviously, that would be the most simplified form of something, okay? But the goal is to just simplify it. We're going to try a whole bunch. So look at the first one. So if you want to, like if you want to screenshot that reference sheet and pull it in so that you can have it like staring directly in your face, you're more than welcome to. But so you're going to get a statement like this, and the goal is to simplify this. What could I do here? Okay, I could make cosine squared become 1 over cosecant squared x. I would say usually, it's not wrong, but usually you want to take something that is a reciprocal function and make it in terms of sine and cosine instead of the other way around. Very rarely do we switch it to the reciprocal function. What's on both of those terms? Sine. So could I factor out a sine x? If I were to factor it out, so I would divide this by sine and I would divide this by sine, I end up with cosine squared x minus 1. Now for me, as soon as I see a statement that has either 2 trig functions squared or 1 with a 1, I go look at my Pythagorean identities. So our Pythagorean identities, how did my colors change? Are sine squared plus cosine squared equals 1. tan squared plus 1 equals secant squared, or 1 plus cotangent squared equals cosecant squared. So none of them are exactly cosine squared x minus 1, but if I look at this top one, can I manipulate that statement so that I could get cosine squared minus 1 on one side? Yeah. If I took and subtracted the cosine, sine squared x would equal 1 minus cosine squared x. Now I'm close, right? What's different? The signs are switched, right? From what I have. Everybody see that? Yeah. How could I switch signs? Multiply by negative 1. So if I multiplied everything by negative 1, I get negative sine squared x equals, this would be negative 1 plus cosine squared, or cosine squared x minus 1 equals negative sine squared x. So I can replace this whole statement, which is this, with negative sine squared x. I end up with sine of x times negative sine squared x, which is negative sine to the third x. So there's 3 signs, the one from the first one and then the squared from the second one. And that's as simplified as it gets. If you can get it down to one trig function, you're as simplified as you can get. Go to 2. What do you see there? Cosecant is there twice again, right? So cosecant x times cosine squared x minus 1. What did we just say is the same as cosine squared x minus 1? Negative sine squared, right? So cosecant x times negative sine squared x. What is cosecant? 1 over sine. So if I change that to 1 over sine times negative sine squared x, I can actually cancel out one of the signs, and I'm left with negative sine x. Three. So now it's all multiplication. There's no addition or subtraction, which means I can usually rule out my Pythagorean identities and see if there's something else I can do. So what's the equivalent of secant? 1 over cosine. What's the equivalent of cotangent? 1 over tan, or what? Cosine over sine. Other way around. Cosine over sine. And then I get another sine. And it's all multiplication, so can I cross cancel? Yup. This cancels with this with this. And my answer is just 1. One of these years I'll remember to start with that example. It's way easier than the other ones. Okay, go to 4. Cotangent squared x and then 1 plus tangent squared. So I have another like 1 plus tangent squared, right? So if I got a sum and it's either 2 trig functions or it's a trig function with 1, I go back to my identities. This one says tangent squared plus 1 equals secant squared. So I can literally replace 1 plus tangent squared with secant squared. Now what? And then what? I have 1 over sine squared x. Is there a simpler way of saying 1 over sine squared? cosecant. Just be careful, don't lose the squared. So that should be cosecant squared. As long as you have it at the answer, I don't care if you lose it, just be careful. In like the realm of verifying identities, every once in a while you'll see one that has two different variables. Like you could have an X and a Y, so I would say keep it in those scenarios. There's not a lot of those, but they could happen. Yeah. All right, so these kind of give you a hint. It actually says simplify by factoring. So all of them are going to involve factoring. If I look at the first one, how do I factor that? Good. Difference of two squares, right? So I can do secant x plus 1 and secant x minus 1. Now that actually doesn't simplify it in any way, shape, or form, but it literally told me to factor it. If I hadn't factored it, I would have gone to the beginning and I would have looked at my trig identities and see if there's a secant plus 1 and I would have used it. But because this is telling you to factor it, you just need to factor it out. All right, 6. 4 tan squared x plus tan x minus 3. So this is one of those scenarios where I would say go back to your like substitution to make things easier to factor. You take the middle term and replace that with a variable. So we're going to say a equals tan x, which means everywhere there's a tangent, I'm going to replace it with a. So the first one would be 4a squared. The second one is just a and then minus 3. And now we want to factor that. So you can either do first times last, which I think is what most of you do, right? First times last here would be 4 times negative 3. Factors of that sum to positive 1. So negative 12 result in positive 1 would be positive 4, negative 3. Replace your middle term with those. And then factor by grouping. So from the first one, you can take out a 4a. Second one, I can take out a negative 3. And I get a plus 1 and 4a minus 3. And then I got to plug back in the tangent. So this would be tan x plus 1 and 4 tan x minus 3. So eventually we will actually have these set up as equations and we'll keep going with that. But for right now, you're just factoring. And by eventually, I mean like in 2 sections, not today. All right, how do I factor 1 minus cosine squared? You could, or you could are those not both perfect squares? They're just not in the order we're used to them, right? But it's still different to 2 squares. Square root of 1 is still 1. Square root of cosine is cosine, or cosine squares is cosine, and one gets plus and one gets minus.
Wait, can't you only do that when like the one is negative because like you have to split it up? Like you
do, but so the negative has to be between them. Yep. And they both have to be perfect squares, and they are. We're used to it the other way around. Like you're used to the squared term being first minus 1, but that's still different to 2 squares.
That's what I mean, because before you used to when we did factoring, when one was positive, one was negative, it's always back to the negative one now.
Right. The negative one is, I mean, I know it's cosine, but it's still the same thing. Yeah. All right, so now we're going to do the replacement again. I'm going to make cosecant x, my a, 2a squared minus 7a plus 6. And then do your first times last. So 2 times 6 is 12. What are the factors of positive 12 that sum to negative 7? Good. And I replace my middle term. And then factor by grouping. Take out a negative 2 here. I get 2a minus 3, and then a minus 2, and then I got to plug the cosecant back in for the a. All right, this is where it gets tricky. Once you understand it, it's not so bad. But in my opinion, when you first look at these, you like have a little freak out moment because those look like they should be the same, but they are not the same trig function, right? One's cosecant squared and one's cotangent x. So go back to your reference sheet, stare at your reference sheet, and find me something that has cosecant and cotangent on there. The last Pythagorean identity says what? So in order to factor this, which is what we're going to eventually do, we have to make those be the same thing, okay? So I can't replace cotangent with cosecant, but I can replace cosecant squared with something else, right? So if I use this and I say cotangent squared, it's 1 plus cotangent squared on your sheet, right? It's the same thing. Cotangent equals cosecant squared. No, sorry, I'm going to rewrite that. Cosecant equals cotangent squared plus 1. I can actually replace cosecant with that. Cotangent squared x plus 1 minus cotangent x minus 3. So if you see two different trig functions and the goal is to like factor something like that, you're going to have to replace one with the other. And you're going to replace the squared term because that's what your Pythagorean identities are. So now I'm going to just combine my like terms, cotangent squared x minus cotangent x minus 2. And now I'm going to factor. So I'm going to do the a again. Cotangent x equals a. This would be a squared minus a minus 2. This time when I factor, I'd get a minus 2 and a plus 1. And then just plug the cotangent back in. All right, so I've got secant and tangent, right? The trig identity you want to use is tan squared x plus 1 equals secant squared x. So which one am I replacing? The secant. You cannot replace tangent. So like I can't replace tangent with 1 or secant minus 1. It doesn't work that way. So secant squared x gets replaced with tan squared x plus 1 plus 3 tan x plus 1. Group tan squared x plus 3 tan x plus 2. If you want to simplify, if you want to plug in, I can make tan x equal my a. So this is a squared plus 3a plus 2. Factor it, and it's tan x plus 2, tan x plus 1, and then plug, well, actually, I didn't. It would have been a plus 2 and a plus 1, and then plug in the tan back in, and that's where your answer should be like tan of x plus 2 and tan of x plus 1. Raise your hand if you got it right. Okay, good. Questions? Okay. Let's do a couple more. So 11, sine of x plus cotangent x cosine. So there's nothing to factor out, right? There's nothing to replace. I know there's no squareds. That usually eliminates my Pythagorean identities. There's nothing with like a pi over 2 minus theta that eliminates my cofunctions. There's no positive negatives that eliminates my even odds, which means you're just going back to the basics, like see if there's reciprocal functions you can cancel out. So what can I replace there? I can make cotangent what? Cosine x over sine times cosine. Now I cannot cross cancel, right? So this becomes sine x plus cosine squared x over sine. Very rarely are you going to leave an answer as two separate fractions. If there are two separate fractions, you actually have to find a least common denominator and get them into one. So what do I do to get a least common denominator? Multiply by sine x over sine x. So I end up with sine squared x over sine x plus cosine squared x over sine x. Now they have the same denominator, and I get sine squared x plus cosine squared x over sine. Then what? You can't. Oh, good question. I mean, I'm glad that you said that. So you can only cancel the sign into there if you can also cancel it into there. If it was multiplication, you could. If it was two separate fractions, you could. But because it doesn't go into both of the parts of my numerator, I can't do anything with that. Any other ideas? Sine squared plus cosine squared is 1. It's a Pythagorean identity, right? And then is 1 over sine x. Simplifiable. Cosecant. So cosine squared and sine squared is 1. It's my Pythagorean identity, right? Sine squared plus cosine squared equals 1. So that whole thing gets replaced with 1, and then you have 1 over sine squared, and that becomes cosecant. Yeah. No. Yeah. You know half of it already. You just got to practice it. Those are the ones that are the hardest. I actually want to see you learn and then succeed. But learning is part of it. Yeah.
So if we don't simplify it all the way to like the cosecant, that answer's wrong.
It's not necessarily completely wrong, but you probably wouldn't get full credit. And that's the hardest part of, I think, and that's the difference between 7.1 and 7.2. 7.2 would start with a question that says this: sine of x plus cotangent of x cosecant x, or cosine x, equals cosecant of x. And it says the words verify the identity. So you know when to stop. You know when you've gotten to the end. I think 7.2 is easier because it is. You have like, I know I got to get it to there. You just got to figure out all the steps in between. Yeah. Yep. So when it says verify, it means more work. Exactly. No. All right. Go to 12. What can we do? Cosecant can be. Okay. One over sine. So I'm back to 1 over cosine squared x over sine x, because they both have the same denominator. As soon as you see that 1 plus or minus something squared, go back to your trig identities. You've got sine squared x plus cosine squared x equals 1. So 1 minus cosine squared x would equal what? Sine squared x. Then what? Good. Now you can cancel out one of those signs, and it's just sine x.
I thought you said that we couldn't like change it.
You can't cancel into part of it. So I can't cancel, like if sine was here and sine was there, I can't cancel that without having to change this. But once you get it down to where this is just strictly multiplication, that'd be like sine of x times sine of x over sine of x. So that's all multiplication, and that can be simplified.
For the Pythagorean, for the theorem, like for the other one, you said that you can't like switch it, like when we did.
You can move it around. You can't switch it for a non-squared and a squared. So if I have 1 minus cosine x, I can't replace that with sine x. But 1 minus cosine squared x is sine squared x. So you can move around your Pythagorean identities all you want. You just can't make them not squareds. They have to be squareds.
How come for number 11 you have to change the denominator of the sine x?
So if you look, the sign was in the numerator here, right? It didn't have a denominator. Here, it's in the denominator already. So they already had the like denominator. All right, sine x over 1 plus cosine x over sine x. So again, two separate fractions, right? Can I give them a like denominator? Can you give any fraction like denominator? The answer is yes. They might be ugly and unpleasant, but what would be the least common denominator here? The whole thing. Sine of x times 1 minus cosine x. So you can't do sine squared because it's not cosine squared. Yeah, that's the trick, or that's the catch with those. So I'd have to multiply this fraction by sine in both the top and the bottom because that's what it's missing. And I'd end up with sine squared x over sine x times 1 plus cosine x. Second fraction, I'd have to multiply by 1 minus cosine x in both the top and the bottom. And I get cosine x times 1 minus cosine x over sine x 1 minus cosine x. So I gave them both the same denominator. Now I want to combine them. Bella. Oh, yeah, sorry. Yes, thank you. I wrote it wrong here and there. That's all plus. So now I could distribute this here, and I would get sine squared x. I'm going to combine my numerators too. Plus cosine times 1, which is cosine x, plus cosine times cosine, which is cosine squared x, all over sine x times 1 plus cosine x. Now what?
Just simplify. No, because the 1 can't go with everything.
Right, I can't divide the 1 up. Nope, yeah. I got to do something with my numerator. Combine what? Because they're not like terms, I can't combine them. They'd have to both be squared to both be cosine to the first. So cosine squared plus sine squared is 1, right? I can rearrange that. Like if you don't see it and you want to rearrange it, this would be sine squared x plus cosine squared x plus cosine x. And these two together are 1. So then it becomes 1 plus cosine of x over 1 plus cosine of x. No, sorry. I didn't write it all. Over sine x times 1 plus cosine x. And then what? I can actually cancel this whole expression with this whole expression. And it becomes 1 over sine of x, which is cosecant of x. Questions on that one? Yeah.
I don't know if you said this, but for the top, when you are adding the cosine x.
This one?
Yeah.
Yeah.
You can't do it because they're like different.
Oh, you can't combine these two together, you mean? Yeah, that's like x plus x squared, right? They're two different terms. I can't combine them. They'd have to have the same exponent. Sure.
And it would be cosine to the third.
Correct. Yep. So I would say if I could give you like the biggest this is the hardest thing, one of the hardest things to teach, because it's not like here's step 1 and here's step 2 and here's step 3, right? Like those to me, I can teach you all day long. Go to the next step, go to the next step. And these are like puzzles and you have to be able to see it. And the hardest thing is to not get frustrated. Your question 1 might throw you off, but question 10 might be the super easiest thing ever. So especially when it gets to the homework, you are not allowed to not try. You've got to at least try something. There's always going to be at least something you could try, and you might replace one thing, and it might be like, oh, okay, maybe I could replace another thing. Yeah. The other thing is that, like, sometimes for what we've done so far today, it seems like there's, like, one good path. Sometimes there's more than one way to get to it. So just because you have a different way of getting to an answer than somebody else doesn't necessarily mean it's wrong, okay? All right. All right, what are you going to do? Like denominators, which would be?
1 plus sine of x and 1 minus sine of x.
Good.
Could you just make can it just be sine of x squared?
1 minus sine squared, you mean? Like when you get to the denominator, you can do that. Yeah. But the numerator, you want to keep it because this one's missing the 1 minus and this one's missing the 1 plus. So 1 times that is 1 minus sine of x. Plus comes from the middle. 1 times 1 plus sine of x stays as 1 plus sine of x all over. And again, you could keep it as 1 plus sine of x, 1 minus sine of x. Or are we good from crossing this one out? Like once you get to this, it's after this that we got lost, right? So if I cross these out, because negative sign and positive sign, this would be 2 over 1 plus sine of x times 1 minus sine of x. And then if I were to FOIL out the bottom, it results in the difference of two squares because it's 1 plus sign and 1 minus sign. So you could FOIL it out. You'd get 1 minus sine x plus sine x minus sine squared x. And then these cancel, 1 minus sine squared x. So that's my new denominator. And then because I see a 1 with a squared term, I go back to my trig identities. If sine squared plus cosine squared equals 1, and I move this to the other side, cosine squared equals 1 minus sine squared, I can replace this whole thing with cosine squared. If you didn't, like if you didn't FOIL it out, you wouldn't have gone as far as you could. Yeah. No, because what can you do with that? Yep. So when you bring something from the bottom to the top or the top to the bottom, it becomes its reciprocal function. So this would actually be 2 secant squared x. So you can move, like if we're so used to taking the reciprocal ones like cosecant and secant and making them their reciprocal signs, right? But you could do the same with your original trig functions. When you move it, you can make it its reciprocal. So if you are moving from top to bottom, if I had 1 over sine, I know that's cosecant. I can do that with any of them. If I had 1 over cotangent, when I move it to the top, it becomes tangent. And you would know for sure you couldn't just leave it the way that it was, okay? So then I would say, okay, I need to work the left side. I need to combine them into one fraction, first of all, or not one fraction, but I need to combine them so that they would be out of the denominators. So I would get rid of by multiplying it straight out. I would multiply 1 times 1 minus sine x, and I get 1 minus sine x. And then the denominators, you'd multiply it, and I'd get 1 minus sine squared x. And then 1 minus sine squared x is cosine, because sine squared x plus cosine squared x equals 1. If I move this over here, I'd get 1 minus sine x over cosine squared x. So then I know secant is in this answer, which means I'm probably going to have to bring that to the top. When I bring it to the top, it becomes its reciprocal function, which is secant. And then I know I can distribute. And now you know it matches that.
Even though like incorrect here, like having that big of an answer.
Not necessarily. Sometimes you can't help it. And sometimes you'll see these are like a matching question sometimes, like if it's a multiple choice, let's say, and you're looking to see like, how do I get that to that? That's when you kind of got to work backwards. So there's, we'll save this last one for, again, I see you Thursday. I won't see you tomorrow, but the homework on WebAssign, the very last one has a verify. It says to take this expression and verify, it gives you the other side. So you want to work through the steps. It's kind of weird how you have to type in your answer. Don't get frustrated if you don't know how to format in your answer there. If you have the work to show the verification, it's fine, okay? But that's the only one that has the equals something at the end. The other ones are just like simplify. The good news is I'm going to give you time in class tomorrow to work on that assignment. So you don't need to do it tonight. You could do it tomorrow in class. If you want to get a head start, you can, but there's only 11 questions. You should be able to do those in class tomorrow, okay? And then you'll turn it in before the end of class tomorrow.
Can you